All right, so today's video is going to focus on solving polynomials. Note that to solve a polynomial means to find the zeros or finding the roots. If those roots are real, they'll be x-intercepts. We'll get into that in just a second. So using factors and graphs is what we're going to use today for understanding polynomial behavior and what happens with their roots. So the first thing I have for you is a warm-up and a review. Find all factors of the polynomial p of x. So I'm going to ask that you pause your video and try to factor. Consider the idea that this has 4 terms, so that might help you in deciding how to start factoring. Go ahead and unpause once you have all factors of this polynomial. Pause. All right, so we factored by grouping, found some GCFs, then this and this, x minus 2, are in both of these terms, so I factored that out in black. And what was left when I factored out the x minus 2 was the x squared minus 16, and then I factored using a difference of squares. So remember this because we are going to come back to this in a little bit. All right, so again, to solve a polynomial, that's our goal for today, means to find all solutions to the function. If your solution is a real number, so no I involved, then you are going to see an x-intercept on the graph, which means you will cross or touch the x-axis, which we'll talk about a little more. Irrational solutions. Irrational solutions are numbers that cannot be written as a ratio or a comparison of two things. Oftentimes we will see those with square roots. So basically you can think for our purposes, square root solutions will come in conjugate pairs. So what that means is if you have an irrational solution of the square root of 19, then negative root 19 must have also been a root. If you had a root of 3 minus the square root of, we'll say, 23, then 3 plus the square root of 23 must have also been a root. If you have, we'll go with 8 plus 2 square root of 51, then 8 minus 2 square root of 51 must have also been a root. Okay, so anything that is irrational, for our purposes, has a square root, will have the plus version and the minus version, which we're used to because anytime we take a square root in solving, we have to introduce that positive, negative, which creates a conjugate pair. So, reminder of methods to solve a polynomial in the order that you should try. We've spent a lot of time going over factoring, and that's what this video is going to focus on. So this will take factoring one step further because the factors can then help you determine your zeros and help you see what the graph is going to look like. The other one we can use is our calculator, and we're going to focus on that when we get to polynomial solving part 2, connecting our division strategies that we've also been practicing. So what do my factors tell me about the graph of my polynomial? Well, if you have a factor, let's say x minus a, that means that x minus a being equal to 0 will create a solution to your polynomial. If x minus a has an odd degree for the factor, that means your graph is going to cross through the x-axis. Okay, so x minus a, that's technically to the first power. We're going to cross through the x-axis at x equals a. If I had x minus a to, let's say, the 5th power, that's an odd number, then I am still going to cross through the x-axis, but if that degree is greater than 1 and still odd, we're going to flatten out first. And again, I'm going to show you what this looks like. The next situation then is instead of having an odd degree, you might have an even degree. An even degree is going to touch and bounce through the x-axis. So for instance, if this was x minus a to the 2nd, we would touch and bounce. Another even number, though, it could be would be something like x minus a to the fourth. That's an even. So if we have something that's greater than 2, we're going to flatten a bit first before we touch and bounce back. And again, I will show you. All right, so use the factored form of each polynomial to match the function with its graph. So graph number 1 has x minus 2, so x equals 2 is a root, x plus 2 means x minus 2 is a root, and x minus 4 means x equals 4 is a root. All of these have first degree multiplicities, okay? So I need to cross through at 2, at negative 2, and at 4. Negative 2 and 4, nope, touching and bouncing. Negative 4 and negative 3, no. Negative 2, 2, ooh, and 4. I think that's my winner. At 2, negative 2, and 4, I am crossing through. So this one matches with, what did I label that? As number 1. All right, let's look at number 2. Number 2, I have x equals 2, x equals 4, and x equals 4. Notice that this then creates a multiplicity of 2. Because instead of writing x minus 4, I could have written x minus 4 squared. So this even power means I'm going to touch and bounce back at 4. So I need to cross through at 2, but I need to touch and bounce at 4. Cross through at 2, touch and bounce at 4. Here we go. Touch and bounce. I don't cross through the x-axis, I just touch it for a brief moment and turn back around. So this is going to be number 2. All right, next one. Here I have x equals 0, x equals negative 2, and x equals 4. Each one of these are 0 one time, so I'm going to pass through 0, negative 2, and 4. 0, oops, I had it. 0, negative 2, and 4. So this one is graph number 3. I'm going to have you pause the video and see if you can determine which graphs match the other 4, 5, 6, and then I'm going to talk through them once you unpause, but see if you can match them first. All right, let's see how you did. So I found x plus 2 had a multiplicity of 3. So that 3 is odd, which means I'm going to cross through, but it's greater than 1, so I'm going to flatten out slightly. So I came up with this graph, it was number 4, because right here, I kind of smooth out or flatten out at that negative 2 root. 5 and 6 were pretty similar. We have a double root at 0, because it's twice. That's what the square is. And we have a double root at 2, because I could have written this as x minus 2 to the second. So I'm going to touch and bounce at 0 and 2. Number 6, I'm going to touch and bounce at negative 2 and 4. So number 6 is this guy, and number 5 was this guy down here, because 0 and 2. All right, based on the factors you found in your warm-up, we're going to try to sketch a graph of this x to the third polynomial. Well, you might remember that our factors were x minus 2, x plus 4, and x minus 4. At least I think those were our factors. Jumping back to here, x minus 2, x plus 4, x minus 4. So each one of these is its own unique factor to the first power. So I have x equals 2, x equals negative 4, and x equals 4. And then some other things that I can consider graphing. I just found my x-intercepts. I know that this has a leading coefficient of 1, and it's an odd degree. So my arrows are supposed to go like this. The other thing I know is that if I were to plug in 0 for all of my x's, my y-intercept is going to be 32. So I'll count by 4s, 4, 8, 12, 16, 20, 24, 28, 32. So that'll be my y-intercept. And then the rest of it, I'm just going to connect in the general shape of down, up. So I'm supposed to pass through to my y-intercept. I'm supposed to pass through. I'm supposed to pass through and keep going. Now, I don't know how low this guy is supposed to go, and that's okay. We're not going to worry about it, okay? It's just a sketch. So important things we'd be looking for in a sketch are the x-intercepts, because that's what you found when you solved the polynomial. If you can find the y-intercept and it's easy to plot, that's helpful. And then we want to make sure that we have the right end behavior of our polynomial. So this was a positive odd, so our arrows are down and then up. All right, find the factors of the polynomial, then sketch the graph. This one I want you to start by factoring and then unpause, compare your factors with me. So you try to factor this one on your own. Pause now. All right, so here's our factors. I factored by grouping and then I had a difference of squares. So now if I go through and I find my zeros, I'm going to get x equals -3, x equals 3, and x equals 3 again, because these two together could have been written as x minus 3 to the second power. So remember, when we have an even power or an even multiplicity, we're going to bounce. So when x is equal to 3, 1, 2, 3, I'm supposed to bounce there. Then I also have x equals -3. I'm supposed to cross through there. Remember, the other good piece of information you can find is that y-intercept. 3, 6, 9, 12, 15, 18, 21, 24, 27. And then this one again is a positive odd. So our positive odd degree polynomial has end behavior that looks like this. So I need to somehow connect my ends. This one's supposed to go down, and then the other one's supposed to go up. So I'm going to have a turn here, and then I'm supposed to touch and bounce and continue on. Something to note, my turn doesn't have to perfectly be at my y-intercept. That might have been a little misleading. This turn maybe happened here and then came back through. But again, we're not worried about that. We just want a sketch, okay? Now, you could confirm all of these, of course, by graphing on your calculator. So if you get stuck and you don't have your calculator, you could always graph on Desmos, okay? Desmos is a great tool to use. But we want to see if we can sketch a graph without needing our calculator. So, just as a reminder, before you apply your learning, if you have an even multiplicity, you're going to see a bounce. If that even multiplicity is higher than 2, it's a bounce where it kind of smooths out a little bit. If you have an odd multiplicity, you're going to pass through. And again, if that odd number is greater than 1, you're going to flatten out a little bit. So go ahead and try these 4 apply your learning problems.